baseline security by protecting your training and development environment, applying trust controls to anything and anyone that enters. Why does this principle exist? The security of the environment in which your model is developed and trained is critical. At the training stage of the life cycle, valuable assets, e.g. training data, come together with external inputs, e.g. software or open-source pre-trained models. This creates a high-value target with multiple possible attack vectors. Damage or exploitation at this stage could enable attacks that propagate throughout your application's lifecycle. This principle concerns protecting this environment. Related discussion of gathering and securing trusted training data is found in 2.2 and 2.4, respectively. Requirements and development, secure your supply chain, and secure your infrastructure. Like your data, the infrastructure that makes up your training environment needs to be sourced through a trusted supply chain, whether that involves locally owned servers, public cloud services, or local training on an embedded device. Supply chain threats should be considered for each specific application and be evaluated against requirements. Developers should understand that initiating development in a less secure research and development (R&D) environment could create attack vectors that could be exploited in production. For example, an adversary could use information about model architecture following reconnaissance of an insecure environment to develop a surrogate model that could be used to develop attacks against a production version. Securing development infrastructure is likely to involve assessing multiple components and settings. It's important to secure the operating system, ensuring you're updated to the latest version, and limiting access to the environment to only those with a legitimate need. Access to and modification of components should be logged and monitored. External components may include third-party software for building, training, and deploying models. Exploitation of software dependencies is an attack vector for adversaries, hence software should only be obtained from trusted sources. It's important to note that securing the storage of training data is not in scope for this principle. This is covered in Principle 2.4, Requirements and Development, Secure Your Infrastructure. Advice on how to secure your deployment infrastructure is in 3.1, Deployment, Secure Your Infrastructure. What are the goals of this principle? You have sufficient quality assurance, QA, or quality control, QC processes for your supply chain, including your digital assets, following best practice. You understand the severity of the risk posed by the combination of valuable assets and supply chain inputs merging at this stage. These inputs may include third-party libraries and frameworks, pre-trained models used directly or for transfer learning, training data and labels. Strengthen your infrastructure. Source assets, including digital ones, appropriately from trusted supply chains. This includes pre-trained parent models for transfer learning. Guidance. Refer to the document NCSC Guidance on Security of Supply Chains. Source software to build and train models, third-party Python libraries, data warehouses, MLOps software, and experimentation or testing platforms from trusted supply chains. Guidance. Verify any third-party inputs, including pre-trained models, are from sources you trust. Use secure software development practices. Guidance. Refer to the document NCSC Guidance on Secure Development and Deployment. Monitor CVEs associated with your development software and library dependencies. The level of monitoring should be proportionate to your security requirements. Guidance. Refer to CVE Common Vulnerabilities and Exposures website. Ensure access to your training environment is appropriately secured while following the principle of least privilege for user access. Guidance. Refer to the following documents: NCSC Cloud Principles, Traditional Cybersecurity Practices, NCSC Cyber Essentials. Secure your firmware operating system. Guidance. Refer to the following documents: NCSC Guidance on Platforms, NCSC Guidance on Securing Windows OS, NCSC Guidance on Securing Ubuntu OS, CI Security on CIS Benchmarks. Implement access logging and monitoring in your development environment. Guidance. Refer to the following documents: NCSC Guidance on Security Logging, NCSC blog about what exactly you should be logging. The NCSC has released pre-made software to support logging, called Logging Made Easy, LME. More information can be found about it on the LME GitHub page. NCSC Guidance on Introduction to Security Logging. Strengthen your people. Ensure your team have an appropriate level of awareness of cyber vulnerabilities and best practices to mitigate them. Guidance. Refer to the following document: NCSC Guidance on Advice for End Users.